Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2022, paper 4, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1a, write 65,400 in standard form. Well, standard form has two parts. It has a mantissa part, which is the digits of your number. It's the detail of the number if you think about it. And then that's rewritten as a number between 1 and 10. So I'm going to write the same digits down, 6, 5, 4, but I'm going to put a decimal point somewhere in that number so it ends up being a number between 1 and 10. So it goes there, 6.54. And then I'm going to multiply it through by the exponent or power of 10 that turns it back into the original number. So here, look, the decimal point started here and we've moved it 1, 2, 3, 4 jumps to put it there between the 6 and the 5. So to turn 6.54 back into 65,400, we'd need to times it through by 10 to the power of 4. Okay, so that's my answer, 6.54 times 10 to the 4. Okay, so I'm guessing that's a typo. That should be a times in there. Sorry about that. So part B, write 8.2 times 10 to the minus 4 as an ordinary number. Now again, this number is made up of an exponent part, which is 10 to the minus 4. Now with negative ones, I just think of that as 4 zeros. So I'm going to write down the 4 zeros, 1, 2, 3, 4, and I'm going to put a decimal point between the first and the second zero like that. So the 10 to the minus 4 tells me that there are going to be 4 zeros, and then again, look, this is the mantissa part here. This is the detail of the number, so the digits 8 and 2, I just write those on the end, 8, 2, like that. Okay, so my number in standard form is going to be 0.00082. Question 2. In 2019, Comet A and Comet B were both seen from Earth. Comet A is seen from Earth every 84 years, and Comet B is seen from Earth every 105 years. Find the next year when both comets will be seen from Earth. Now, this question is actually a lowest common multiple question because if you think about it, we just need to work out what's the lowest common multiple of 84 and 105, and then that will be the number of years that they will then take to be in the same to arrive at the same time again. So we could, in theory, just kind of start listing them out. So 84, 168, and so on. That might be one way to do it. But these numbers are large, and they're also quite far apart. So I've got a feeling it could be millennia before we actually meet these two comets in the same year again. So I'm going to use a different method. I'm going to be using prime factor decomposition to do this. So I'm going to first write these numbers both as a product of their prime factors. So on the calculator, so I'm going to be using the new Casio calculator in this paper. And on this particular model, to turn something into a product of its prime factors, you type in the number first, 84, and then you press equals. And then we're going to press the format key, and then we're going to go down to this one that says prime factor. And then that should write it as a product of its prime factors, which comes for 84 to be 2 squared times 3 times 7. Okay. Going to do the same thing with 105. So 105, execute, and then I'm going to press the format key and go down to prime factors, and then that should tell me the answer. I get 3 times 5 times 7 for that one. So 105 is equal to 3 times 5 times 7. Okay, so then my LCM is going to be every base that appears. So I've got a 2 in that one, and the highest power of 2 that appears is 2. So it's every base that appears to the highest power that it appears. So I've got a 2 to the power of 2, that's the highest one. I've got a 3 in both, and the highest power of both is just 1. So I'm just going to have a single 3. I've got a 5 in 105, and that's power 1. So I'm going to have a single 5 in my LCM. And then finally I've got a 7 and a 7, and the highest power of that in both is just 1. So I'm going to have a 7 in my answer too. Okay, so I'm going to get 2 squared times 3 times 5 times 7 as my answer. So what's that then? 2 times 2 times 3 times 5 times 7. That comes to 420. Oh, it wasn't that far then. It wasn't millennia. It was 420 years. Perhaps it would have been quicker just to write them all out. I don't know. Anyway, I like that method. 420. So now we know the number of years it's going to take for this event to happen again, but just be careful here because it says find the next year when both comets are seen on Earth. And we've just worked out that it's going to be 420 years later, but 420 years later than what? It's going to be 420 years later than 2019 then, isn't it? So then the year is going to be 2019, the year 2019 plus those 420 years. So what's that then? 2019 plus 420, that's 2439. So 2439, you're going to have to wait a long time to see them occur at the same time again. So 2439. Question 3, an examination has 3 papers. Paper 1 is marked out of 60, paper 2 is marked out of 40, paper 3 is marked out of 100. The 3 marks are added together to form a total mark out of 200. A student scored 65% on paper 1 and 70 on paper 2. Find the mark they now need to get on paper 3 to achieve 64% of the total marks. You must show your working. Well, we need to work out what all these percentages we've got first, to work out how many marks we got first on paper 1 and 2, then we can work out how many marks we need on paper 3 then, don't we? Okay, so paper 1 is marked out of 60 and the student scored 65% of that. So what we need to do is work out 65% of 60. Now with percentages, I like to use this triangle, final, original, multiplier to work out what to do with percentages. Now here, I want to work out the final mark because I know what the mark was, the paper was originally out of, and I know the percentage for each of these questions. I'm going to be finding the final for these. So covering up the final, that tells me that the final equals original times multiplier. Okay, so that's the calculation I'm going to be doing for each of these. I'm going to take the original one and multiplying it by the multiplier. So for paper 1, it was marked out of 60, so the original mark was 60. So 65% as a multiplier. You just need to divide it by 100 or just rewrite it as a decimal. It's pretty easy, it's 0.65. And then if you type that into a calculator, 60 times by 0.65, that comes to 39. So you scored 39 marks on the first paper. Okay, now paper 2 was marked out of 40, and we're told that he got 70% on that. So to work out the number of marks then, that's going to be the total marks, the original marks, times the multiplier of 0.7, and that's going to give me 40 times 0.7, that's 28 marks. Okay, now he wants to score 64% overall. Okay, now we know that the total marks out of everything is 200, so to achieve 64% of the total marks is going to need 200 times 64% written as a decimal. That's 0.64, and that comes to, I think it's 128 just off the top of my head. You can verify that on the calculator if you wish. So what has he got so far? He's got 39 and 28 so far, so 39 plus 28, that comes to 67. So he's got 67 marks already. Okay, now to get 64% overall, he needs 128 marks. So what's the difference then? So if I take away the 67, we should be able to work out the number of marks he still needs to get. So 128 minus 67, that comes to 61. Okay, so he's going to need to get 61 marks in paper 3 in order to bump up his amount to 64 overall. Question 4. A phone manufacturer records the faults that are reported. Last week, in a batch of 96 phones, 6 were reported as faulty. Write down the relative frequency of faulty phones in this batch. Okay, well, relative frequency is given as successful trials divided by total trials. Okay, now successes doesn't necessarily mean a good thing, it just means the one we're talking about. So in this case, success is that the phone is faulty, weird but true. So there were 6 successful trials of achieving a faulty phone over a total of 96 phones altogether, so 96 trials altogether, so 6 over 96. Now you could cancel that down, but you don't get any extra marks for doing it, so I'm just going to write it out like that. In 2020, the manufacturer sold a total of 12,321 phones. Work out how many of these phones the manufacturer should expect to be reported as faulty. So expected number of successes is going to be the relative frequency of success times the number of trials. Okay, so in this case we just worked out the relative frequency to be 6 over 96, and the number of trials is given here, look, is 12,321. That's the number that was sold, 12,321. So multiplying these two things together, so 6 over 96 times by 12,321, that comes out to be 770 and change. So I'm just going to round that down, 3 significant figures, that should be fine. So I'm just going to go for 770 phones. Okay. Question 5. B is 12 kilometers due east of A. C is southeast of A and on a bearing of 225 degrees from B. Complete the diagram to show the positions of A, B and C. Show clearly the values of all 3 angles in triangle ABC. The scale is 1 centimeter, represents 2 kilometers. Okay. And we've got the point A marked and a north line drawn. So we're going to have to use a protractor and a ruler to do all these measurements and make sure we draw our scale correctly. Okay, so first off, we know that B is 12 kilometers due east of A, and east is on a bearing of 90 degrees from north, isn't it? So if I mark with my protractor 90 degrees from the north line, then I know that B is going to be somewhere along this line. Okay, right, so how far exactly is it? Well, we know it's 12 kilometers and we've been given the scale of 1 centimeter represents 2 kilometers. So to draw 12 kilometers, we're going to have to say, well, that's 6 centimeters, isn't it? So carefully measuring along my ruler 6 centimeters and then stop in. That is going to be my point B. Okay? Right, so let's just mark B. Now, next up, point C, we're told, is southeast of A on a bearing of 225 from B. Okay, so we've got measurements from A and from B. So we can maybe if we draw those 2 lines on, then C is going to be in the intersection. Okay. Before I do that, let's just have a think about what all these various angles are. So southeast, what's that as a bearing? Well, it's going to be 135 degrees, isn't it? Because if I draw the compass up, north, east, south, west, then north is on a bearing of 0, 0, 0, east is 0, 9, 0, south is 1, 8, 0, and west is 2, 7, 0. So southeast is going to be halfway between 90 and 180, so that's 135 degrees. Okay, so again, using my protractor to measure around from the north line 135 degrees, then I know my point C is going to have to be somewhere along this line. Okay, now I don't know exactly where yet, but I do know it's somewhere along this line. So let's just draw that on for now. Okay, I don't know how long the line needs to be, so let's just make it quite long. Next up, we've got to draw this bearing of 225 from B. So what direction is 225? Well, if you remember, south is 180 and west is 270. It's going to be kind of southwest, isn't it? Okay, but we need something to draw from. We need a north line first on B, don't we? Okay, so reaching for a set square, if I put that on my line that I know is running east-west, then because the set square has got 90 degrees, I can just kind of draw off that. I can just quickly draw the north line off that line there. Okay, so that's my north line. So that's where I'm going to be measuring my bearing from. Okay, so I've got to go on a bearing of 225, but again, I've got a slight issue in that protractors only go up to 180. So a bearing of 225 is beyond the edge of the protractor. Okay, so what I'm going to do is I'm going to work out this inner angle here. So that's going to be 360 minus 225, isn't it? Which comes to, what's that? That's going to be 135, isn't it? Okay, so I'm going to measure back from the north line this time, an angle of 135. Right, remember I'm going to have to be using the inner track of the protractor this time because the out one starts on 180, the inner one starts on 0. So coming around to 135 and marking it there. Okay, then I know that my side and my C is going to be somewhere along this line too, then, isn't it? Okay, so it's going to be somewhere along this line on a bearing of 225. Right, so we can see that the two lines meet. That's going to have to be point C then, isn't it? Okay, now it says we also need to show clearly the values of the three angles. Now, the first two I can probably just calculate, can't I? Because I know I was going, AB is directly east, which is 90 degrees, and AC is on a bearing of what was it? It was 135, so the difference between the two of them is just going to be 45 degrees. Okay. Similarly, if I think about that angle there, it's going to be the difference between 270 and 225, so that's also 45. So that means the angle down there must be a right angle then, isn't it? Because 45 plus 90 equals 180. I'm just going to double check, make sure it is actually 90 degrees. I think you can see there it's spot on, isn't it? So I'm pretty happy with that. Good, job done. Let's move on. Question 6a. A solid block of wood is a cuboid which measures 3 by 4 by 5 centimeters. Its density is 0.65 grams per cubic centimeter. Work out the mass of the block of wood. Okay, so this is a problem about density. So I'm going to be using the density triangle thingy widget. So drawing a little triangle with density, mass and volume on it. That's what we need for this one. So mass, density, volume. So usually with these things, they give you two of them and you need to find the third thing, don't you? And you can use the triangle to remember which way round you do things. Okay, so what have they given us here? Have they given us the mass? No, they haven't. Work out the mass of the block of wood. So that is actually what we need to find out, isn't it? So that is our unknown that we're trying to find. Do we know the density? Yes, we do. It's given here. Its density is 0.65 grams per cubic centimeter. So let's write that down. 0.65 grams per cubic centimeter. Okay, finally, do we know the volume? Well, we've not been given the volume, but we've been given the measurements of the cuboid. A cuboid's volume is length times width times height, isn't it? Length times width times height. And we know all those things because they were given in the question. So that's 3 times 4 times 5. 3 times 4 is 12, times 5 is 60, isn't it? So that's 60 cubic centimeters. So that's our volume. 60 cubic centimeters. Now I just need to check that our units are compatible, and they are here, aren't they? Because I've got cubic centimeters there, cubic centimeters there. I've got grams here. Well, that's what this is going to end up as, isn't it? That's going to end up in grams then in these questions. So cover up the thing I want to find on the table, on the triangle. I find mass. That tells me what to do with the other two. So mass equals density times volume then, isn't it? So write down the formula. Mass equals density times volume. Subbing in what we know density is 0.65. We know that the volume is 60. So multiplying those two things together then, 0.65 times 60, and that comes out to be 39. 39 what? It's going to be grams, isn't it? We decided that already. It's going to have to be grams. So that's 39 grams. So I can just write that straight on the answer line, 39 grams. Part B said, here are two areas. Area A has got an area of 0.12 square meters. And area B has got an area of 95,000 millimeters squared. State which area is greater, show you decide. Okay. Now we need them both in the same unit, don't we, if we're going to compare them. It seems sensible seeing meters squared as a decimal. Let's convert them both into millimeters squared. Okay. Now, how many square millimeters are there in a square meter? Well, if you think in a meter, 1 meter is 1,000 millimeters, isn't it? Okay, so but that doesn't mean I just need to multiply that by 1,000, because that's just 1 meter and we're dealing in square meters. If you think about it, another meter going in this direction is another 1,000 millimeters. Okay, so 1 square meter, 1 meter by 1 meter, is going to be 1,000 millimeters by 1,000 millimeters. In other words, 1 meter squared is worth 1,000 times 1,000, or 1 followed by 6 zeros. It's 1,000,000 square millimeters. Okay, so to convert that area A into square millimeters, I'm going to multiply it through by 1,000,000. So that is going to be 120,000 square millimeters then, isn't it? Okay, so which one is bigger? A is bigger. Area A is bigger. Okay. Oh, it's got a little section we need to fill out. So area A is greater because 0.12 meters squared is equal to 120,000 millimeters squared, which is bigger than 95,000 millimeters squared. Okay, kind of nailed that one, I think. Question 7, part A. Construct the perpendicular from the point P to the line AB. So you need a compass with a short pencil. Try and make sure the tip of the pencil and tip of the compass is in the same place. Make sure you've got a pencil which is small so you can kind of fully rotate your hand. Now the first thing I'm going to do is going to mark 2 points on the line AB which are equidistant from the point P. Okay, so I've made 2 marks, look, there and there. Now these are going to be so I can form the perpendicular bisector. So coming to the first mark, I'm going to draw an arc between the 2 lines, like that, all the way around. And I'm going to go and switch over to my second mark that I made. Not the arc I've just drawn, but the one before. And I'm going to draw a second arc like that. And you should see that these two meet in 2 places. One of them is point P, and the other one is a point on the opposite side of the line. Okay, so putting my ruler carefully between those 2 points, I'm now able to draw the perpendicular bisector, or the line that is perpendicular from P to the line AB. Okay, so just drawing that on there. And you should be able to see that that is definitely a 90-degree angle. You can measure it if you like, but I'm pretty confident that's spot on. Right, job done. So the trick was to do those 2 marks first of all, wasn't it? Because I needed 2 marks that were equidistant from point P in order to start the construction of the perpendicular bisector. So a little bit tricky that one, but we got it done. Part B, the diagram shows a field LMN. A tree is to be planted in the field so that it is the same distance from the fences MN and ML, and the same distance from corner M as the corner N. Show by construction whether this can be done or cannot be done. Okay, and we've got a space to say if it is or isn't on the answer line. Right, first off, I'm going to make this same distance fences MN and ML. That's an angle bisector, and to do that I need to put the compass tip at M and draw 2 arcs that cross the 2 lines ML and MN. Okay, so you can see those 2 marks there. Then move your compass tip to each of those marks and draw another arc in between and from the other one on ML. And you should find it forms a little cross which is between the 2 lines. Okay, and that is the direction that my angle bisector is going to go along. So from M through that cross, that should be the points that are equidistant away from ML and MN. Okay, now next we need the points that are the same distance away from the corners M and N. Now that is a perpendicular bisector. Now to draw a perpendicular bisector, just make sure that the aperture of your compass is like between a bit more than halfway between your points. I normally go for about 2/3. Okay, and then we're going to put the compass tip at N and draw an arc between them. Okay, and then coming back to M. It's the same construction from part A, isn't it? And we're going to draw another arc between them like that. So that's going to be my perpendicular bisector. Okay, so drawing a line through those 2 crosses and out the other side. Okay, so there we go. Now you can see that the 2 lines meet down here, and that is not in the field, is it? So the point that meets both rules is both the same distance from MN and ML, this point here, and also same distance from M and N. It lies outside the field. So I'm just going to write that down. Does not lie in the field. Oh no. So if it doesn't lie in the field, then it's not going to be possible then, is it, for this this tree to be planted in the field then under those conditions. Okay, so just at the bottom there in that space I need to write down this cannot be done. So it can't be done, can it? So I'm just going to write down in there this cannot be done. Question 8. A bag contains 35 balls. Each ball is either red or green. The ratio of red balls to green balls is 3:2. Work out the smallest number of balls of each colour that have to be added to the bag so that the ratio of red balls to green balls becomes 7:3. You must show your working. Okay, so we've been given the ratio to begin with. The ratio of red balls to green balls is 3:2, and we know the total number of balls in the bag. Okay, so we can do like a dividing by ratio method to work out how many red balls and green balls there were to start with. Now, if you want to divide by a ratio, you need to take the ratio itself, 3:2, add the 2 numbers together, because that tells you the number of shares there are altogether. So 3 plus 2 is equal to 5. So then what we want to do is we want to divide 35 by that number of shares, and that will tell us how many there are in each share. So 35 divided by 5 is 7. Okay, so that means that the ratio of red to green, which started off as being 3:2, if we scale that up by the number of balls in each share, which we worked out to be 7, then we should work out the number of red balls and green balls that there are. So 3 times 7 is 21, so there must be 21 red balls, and 2 times 7 is 14, so there must be 14 green balls. Always worth just double checking that those 2 numbers add up to your original number. They do. 21 plus 14 is 35, so I'm feeling confident I've done it right. Okay, so that's the number of balls that we're starting with. Now we need to work out the smallest number of balls of each colour that have to be added to the bag so that the ratio of red balls to green balls becomes 7:3. Okay, so now we need to take our 21 red balls and 14 green balls and add a few red and green ones to it so that the new ratio becomes 7:3 then, doesn't it? Okay, now obviously this number on the left, the red one, needs to be a multiple of 7 then, doesn't it? 21 is a multiple of 7 at the moment, but I don't think that's going to work out because the green one also needs to be a multiple of 3 and 14 isn't. Now if we added 1 to green, that would make green 15, but that doesn't help us because 3 goes to 15 5 times. So if we add 1 green, so if we add a green one in here and make 15 balls, that divides by 3. I'd have to divide it by 5, wouldn't I, to get 3? But I can't divide 21 by 5. But if I added a few more balls to it, maybe I could find a number of balls there that if I divided it by 5, I'd end up with 7 then. So 5 7s are 35. So I guess if I added 14 in here, then that would give me 35 red balls and 15 green balls, which then, if you divide both sides by 5, is going to give you the required ratio of 7 to 3. I think that works. Okay, so the number of red balls added to the bag, I'd need to add 14 red balls, and the number of green balls added to the bag, well, I just added 1, didn't I? So altogether, we added 15 balls. I think that is the smallest way of doing it, because literally I only had to add 1 green ball to get 15. Any other multiple of 3, I've had to ended up adding more green balls, and therefore I'd have added up a lot more red balls. So that is definitely going to be the smallest addition. So yeah, feeling good about that answer. 14 and 1. Question 9. Here are 2 pieces of work. For each one, describe the error in the method and give the correct answer. So question: rearrange y equals 3x plus 17 to make x a subject. So what is this person done? Well, they've started with the formula y equals 3x plus 17. They have shifted the 17 from there over to the other side somehow, and then they've divided through by 3. I think that is the error there, isn't it? So normally there's 2 ways of rearranging. Either you do something called change sides, change signs, and then what that does is, so if something's positive on one side, if you move it over to the other side, you get negative, don't you? So your y equals 3x plus 17 would become y minus 17 is equal to 3x. That's one way of thinking about it. The other way maths teachers teach it, obviously, is do the same to both sides. Do the same to both sides to keep it balanced. It's usually if you've been introduced to equations as a balanced model. So if you've got like y equals 3x plus 17, then you would take 17 away from both sides, wouldn't you? That's the way you think about it. It would cancel here, and it would give you 3x is equal to 7 minus y minus 17. So it gives you the same answer. It's just a different way of thinking about it. So some people think about change sides, change sides. Some people say do the same to both sides, but otherwise it gives you the same answer, and that is what has not been done clearly in both of these cases. So he's kind of added 17 to the left hand side, which doesn't cancel out, so you're not taking away, you're not doing the same to both sides, or you've not followed the change sides, change signs rule. Either way, the error is should have subtracted 17, not added. Okay, so what is the correct answer? No, the correct answer, well, we've done the first step here, so then if we divide both sides by 3 after that, okay, that's going to leave me with y minus 17 over 3. So that's the true answer. X equals y minus 17 over 3. Okay, let's have a look at B then. Rearrange a equals 4x squared to make x a subject where x is greater than 0. Solution: a equals 4x squared, taking the root of both sides, root a equals the root of 4x squared. That tells me that the root of a equals 4x, and therefore x equals root 4a over 4. Okay, well, I think I've spotted the error, and that is in here. This is the error here, when we move from here to here. Okay, this is where we went wrong, because they've square rooted x squared to get x, but they haven't square rooted the 4. If you think about it, root 4x squared, you could break into the root of 4 times the root of x squared, and the root of 4 is 2, and the root of x squared is x. So you should have got 2x there. So that's where the error went wrong. So to describe that in words, the error is did not square root properly. And so the correct answer would be, so at that point there, I should have had root a equals 2x. So dividing both sides by 2, I should have got x equals root a over 2 and not root a over 4. So x equals root a over 2. I might just say should have rooted the 4, just to make sure. I don't know how much detail they want for these. I think I always put too much down actually, but hey ho. Better than too little. Question 10, you may use these kinematic formulas to answer these questions. So we've got a couple of the SUVAC formulas here. V equals u plus at and s equals ut plus half at squared. Very useful formula. A particle has an initial velocity of 3 meters per second. After 20 seconds, the particle has a velocity of 11 meters per second. Work out the distance the particle has traveled after 20 seconds. Okay, so I called these some of the SUVAC formulas, and these are the values that they give you in these formulas: S, U, V, A, and T. Okay, so that's why I called them SUVAC. So S weirdly stands for the distance. U is your initial velocity. V is final velocity. A is acceleration. And T is time taken. You're probably asking, why is it not do that? But I don't know. I don't know why they go for S rather than D for distance. Bit weird. But anyway, so what we've been given here. So what I usually do with these questions is I write the anagram down like this, SUVAC, and then I see what I've been given. Okay, and then what I need. Particle is the initial velocity of 3 meters per second. So initial velocity 3 meters per second. That's the U of the SUVAC, isn't it? So that is 3 meters per second. After 20 seconds, so that's T, isn't it? So T is time 20. Okay, the particle has a velocity of 11 meters per second. So the particle has a velocity of 11 meters per second. So that is your final velocity then, isn't it? So you got initial velocity of 3, final velocity of 11. Work out the distance the particle has traveled after 20 seconds. So the distance, that's the one we want to find then, isn't it? Okay. What about A? Don't really care about A. Doesn't ask about A. Don't want to know about A. But it's a slight problem in that both those formulas have got an A in them. So how can I work out distance? I think the problem is here. Both formulas feature A, and I haven't been given A, and I haven't been told about A. Don't know about A. So what we need to do is kind of calculate what A is first, and then we can use that second formula, that S formula for finding distance, because the S formula for finding distance has got an A in it. We don't know A. Okay. So I think what we're going to do is we're going to take the first formula and we're going to rearrange it for A. We're going to sub in what we need from our SUVAC formula here to find out what A is. And once we know what A is, we can then go on and use the second formula to work out S, the distance. Okay, sound like a plan? So we're going to go for A first. So then taking this first equation here and rearranging it, what we're going to get. So V equals U plus AT. So subtracting U from both sides, I'm going to get V minus U is equal to AT, and then dividing through by T, I'm going to get A is equal to V minus U over T. Okay, so I'm going to use that formula for working out A. So then A is going to be V 11 minus U 3 divided by T 20. So U was 11, wasn't it? V was 3, and T is 20. Okay, so 11 minus 3 over 20. What's that then? 11 minus 3 is 8 divided by 20, and that's 2/5. I think I'm just going to leave it as 2/5 for now. I like fractions. Fractions are your friends. Decimals are demons. So there we go, 2/5. So now I know what A is, super handy. So now I can go on and work out what S is. So I know now that A is 2/5. So let's just add it into the table there. Do you know what the unit is? It's going to be meters per second, isn't it? Or meters per second squared. Okay, so that's what that one is. So now let's work out s. Don't have to do any rearranging for s. It's already s is equal to. So using s equals ut plus a half at squared, and subbing carefully into that. U then, u's going to be 3. T is 20. Okay, so we got that from there. That's t plus a half. A we worked out a minute ago. That is 2/5. And then t squared. What was t squared? T squared is 20 squared then, isn't it? Okay, so then we just need to tap that all into the calculator and work out what it is. So I got 3 times 20 plus a half. I'm just going to type that as, well, let me use the fraction key. So 1/2 times 2/5. 2/5 times 20 squared. Okay, just double check that. 3 times 20 times plus a half times 2/5 times 20 over 2. Looks good to me. That comes out to be 140. 140. What's the units then? Everything's in meters per second, so that's going to be in meters then, isn't it? 140 meters. So work out the distance particles traveled after 20 seconds. It's going to be 140 meters. Well, that was a lot of fun. I like that. It's good. Question 11. The diagram shows 2 right-angled triangles that are joined together. All measurements are given accurate to 2 significant figures. Work out the value of x. Give your answer correct to an appropriate degree of accuracy. You must show your working. Okay. Now, with right-angled triangles, in order to work out any side or angle, you need to know 2 things in the triangle already. Okay. Now, the problem with finding x, it's in a triangle where we only know one thing. We know that the side is 8.3 currently. So in order to work out x in that right-angled triangle, we need to know another thing. And so the way we do that is when we've got 2 triangles pushed together like that, they tend to have a communal side. In this case, it's this side here. What we're going to do is we're going to use the left-hand triangle first to find that communal length there, and then we'll know 2 things in the second triangle, and then we can go on and find x. Okay? So, in the first triangle, okay, I've got a right angle there, I've got 42, and I've got 5.4. So in this triangle, using trigonometry, what have we got then? So I'm going to write down SOHCAHTOA. SOHCAHTOA. What have we got here? So this side here is the opposite, this side is the adjacent, this is the hypotenuse. Okay, so in this case I've been given the adjacent. I want that opposite side, don't I, because that's the one that's communal between the 2 triangles. I don't know about h, don't really care about h, not bothered about h. So any of the trig formula that got h in them, they are not the one I want. So I kind of rule out the ones that I don't want. That only leaves that one there. It's tan, isn't it? Okay, so I'm going to use the tangent ratio. So I'm going to write the ratio out in full first. Tan theta is equal to opposite over adjacent. I would suggest that you remember these with the angle in. A lot of people just write tan equals op over adjacent, and then they struggle because they don't know where to put their 3 values in. Okay, so I always write the theta in there. It stands for the angle, and then we're going to sub into that then. So tan angle is that one there, look, 42, so tan 42. So good job I had a placeholder for it, isn't it? And then that's equal to the opposite, which is the one I want to find. Let's call it y for now, because they didn't give it a letter, and then divide that by the adjacent, which I know is 5.4. Okay, rearranging for y, just going to cross multiply that 5.4. I'm going to get 5.4 tan 42 is equal to y. Okay, so matter of just tapping that into the old calculator now. So 5.4 tan 42. That comes out to be 4.86 and change. I'm just going to write down 4.86, but I'm going to keep, well, I'm going to write down an extra digit. I'm going to write 4.862. I'm going to keep the whole display on my calculator. I'm going to use it in the second part of the calculation so I don't lose accuracy. Okay, so I know that this one now is roughly 4.862. Now switching to the other triangle then. So now I know that this is 4.862, and I know this is the x side that I want to find, and this is 8.3. Okay, so this is a right angle triangle where I know two sides and I want a third side. So this looks like a job for Pythagoras theorem. Which says c squared, the longest side, which x is equal to the sum of the squares of the other two sides. It's a squared plus b squared, isn't it? So I'm just going to take my two numbers that I was given, well, the number I was given, 8.3 squared, plus my horrible long decimal, 4.862 squared. But I'm going to use the calculator value, remember. That's still on my screen, so I'm just going to take that value and square it first. Then I'm going to add on 8.3 squared. That's giving me a total of 92.53, and then I'm going to root that. Root answer. So then I'm going to get C is equal to 9. We'll just quickly write that down, 92.53. Again, I'm writing 4 digits, but I'm keeping the whole display for my next value. So then C is going to be the root of that then. So root in the answer, root answer, that gives me 9.62. Okay. Units, I guess is going to be centimeters, isn't it? So X is equal to 9.62 centimeters. Okay, now I think 3 significant figures is appropriate. I used lots more than that throughout the calculation. So yeah, I think it's fine. 9.62. Question 12. The diagram shows a sphere and a cone. The sphere has radius 4 centimeters. The cone has radius 15 centimeters and a height of 30 centimeters. The sphere is completely filled with water. The same amount of water is poured into the cone. Work out the depth in d centimeters of the water in the cone. You must show your work in. Now, in the cone, you can think of it as like a big cone, little cone. You've got like the big cone, which has got a height of 30 and 15, and within that you've got like a smaller cone, which is got height d and radius we don't know yet. Okay, but you should know that these two cones are similar. They're always going to be similar shapes. Okay, so cones are similar. And what does that mean? It means that all the lengths are in the same ratio. So I don't know if you can see that on the big cone, this is 15 and this is 30. Okay, so the height of the cone is twice the radius. So that is going to be true on the other cone as well, the similar smaller cone, that this one here is going to be twice the radius. Okay, so that means that the radius of the small cone is going to be, well, because the radius of the big cone is half the height of the big cone, then the radius of the small cone is going to be half the height of the small cone. It's going to be d over 2. Okay, so the radius of the small cone is d over 2. That's my r value there. Okay, so we can then work out what the volume of the cone is. Now that's going to come in useful later on, but first I think we're going to need to work out the volume of water that we've got to start with. What is the volume from the sphere? That is going to be 4/3 of pi r cubed. Okay, so subbing in what we know that the radius of this is going to be 4. So sub that in. I'm just going to leave it in terms of pi for now. So what I've got 4 cubed times 4 over 3. That pretty much comes out to be 4 to the power 4 over 3. So what's that? 4 to the power 4 divided by 3. That's 256 over 3. So I'm just going to say that that is equal to 256 lots of pi over 3 for now. If I put pi in, it will just get a horrible decimal, and it's just going to be more of a hassle when I sub it into the other side. So I'm going to leave it like that for now. Right, now switching over to the cone, I've got, well, it's going to have the same, that's going to be the same as the volume of the sphere. So I'm going to sub that in on that side. But on the other side, I've got like 1/3 pi r squared h. So I know the radius is d over 2, and I know that h is d. So I'm gonna sub those two in. So I'm going to get 1/3 pi times the radius squared, which is d over 2 squared, times the height, which is d. Okay, just need to do a bit of tidying up here. Well, I think what I'm going to do, I can do straight off, is I'm going to cancel that 3 with that 3 and that pi with that pi. Okay, can you see that? And that's just going to leave me on the left with 256. That should help a lot with tidying it up. And then I've got d over 2 squared, so that is d squared over 4 times d, so that's d cubed over 4. So d squared is d squared times d is d cubed, and the 2 on the bottom it just comes 4. Okay, hopefully that's clear. So I've got d cubed over 4 is 256. So cross multiplying the 4, I'm going to get 4 times 256, that's 1024. So d cubed is 1024. So then cube root of that. So cube root, that's 10.07. So I'm just going to round it off to 10.1. So then d is equal to 10.1. Question 13. Y is directly proportional to the root of x. Y is 1 when x is 16. Find the formula for y in terms of x. Okay, so we've got a straightforward proportionality question here. Now, first off, y is directly proportional to the root x. So I can write that down as y equal fishy root x. This is the symbol for proportionality, isn't it? It's not an equal fishy. So y is directly proportional to the root of x. We can then take that symbol of proportionality and replace it with equals k. So that becomes y equals k lots of root x. So I've replaced the symbol with that. Okay, and then you'll notice that they give us a pair of values that go together when y is 1, x is 16. So we're going to sub those in so we can work out what that value of k is. So when y equals 1, x is 16, so subbing those in, 1 is equal to k lots of root 16. Okay, so subbing in the 1 and the 16. So the root of 16 is 4, so that means that 4k is 1, which means k is a quarter then, isn't it? So therefore the equation, the full equation, is y equals a quarter of root x, which is the same thing as root x over 4, isn't it? So that's my answer, y equals root x over 4. Question 14. An estimate for the number of seals on an island is given by the formula p equals 5,200 times 1.02 to the power of t, where p is the number of seals and t is after the start year of 2015. Write down the annual percentage increase in the number of seals on the island. Now we can just work that out very quickly from this. So this is the, that's my multiplier, isn't it? So if I'm multiplying through by 1.02, 1.02 as a percentage is equal to 102%, isn't it? So 1.02 is 102%. But when you're doing the percentage increase, it's the value above or below 100% is the actual increase, isn't it? So that is a 2% increase. Okay, so 100% plus 2% is 102%. So use the formulas to show that there may have been about 4,700 seals on the island at the start of 2010. Okay, so what's going on here? Do we have to kind of work backwards? So this number here, the 5,200, is the number of seals. So in 2015, there were 5,200 seals. Okay, and what we want to do is we want to work backwards to 2014. We can't just use that 4,700 in our calculation because we need to show it. Okay, so between 2010 to 2015, that's a gap of 5 years, isn't it? Okay, we know that the percentage increase is 2%, and we know that the number of seals that we started for in 2010, let's call it X. If I multiply that by 1.02 to the power of 5, and I get 5,200, because that's the number of seals at the beginning of 2015. So then if I rearrange that, I could just say then that X must be equal to 5,200 divided by 1.02 to the power of 5 then, and work that out. So what is that then? So 5,200 divided by 1.02 to the power of 5. Oh, look at that, comes out to be around about 4,700. It actually comes to about 4,709.8, which is roughly 4,700, isn't it? So rounded off, it is 4,700. Question 15. The cumulative frequency graph shows the distribution of the ages of members of a tennis club. Yep, a very nice cumulative frequency curve. Part A says the table summarizes the ages of the members of the cycling club. So this is a different club, isn't it? So we've got the tennis one already drawn, and now we've got data for the cycling club. On the graph above, draw the cumulative frequency graph of the ages of the members of the cycling club. Okay, so we need to draw another cumulative frequency curve on the same axes using this new data. Okay. Right, now cumulative frequency curves need cumulative frequency, so we're going to need to calculate that first. So just going to add an extra row to my table, cumulative frequency, and I'm going to work out these. Now the cumulative frequency is added up all the way across, isn't it? So the first cumulative frequency is the same as your original frequency. The next one we're going to get by adding those two together. So 8 plus 14 is 22. And then the third one we're going to add all three together. So it could take me to 30, and then 42, and then 59, and then 64. So yeah, it should add up to 64. Does it? Just going to double check. 22, 30, 42, 59, 64. Yeah. Okay. So then what we do is we plot upper class bound against cumulative frequency. So the 20 goes with the 8. So from a, but actually I can plot a bonus point here on the lower bound of the first one. So I am going to plot a point at 0, 0. Then I've got a point at 20 along and 8 up. So we've got 1 square is 1 on here. So it's a nice easy scale to use. Then I'm going to plot 30 against 22. It's always the upper class bound you use for cumulative frequency. So 30 and 22. 40 and 30. So 40 goes with 30. A bit of a wobble there on the cumulative frequency. And then 50 goes with 42. 70 goes with 59. Eyes are going a bit wobbly. Look at all these little lines. And then finally 80 goes with 64. 80 goes with 61, 2, 3, 4. They end in the same place up there. Okay. So now we just need to draw that together with a nice smooth curve. It's got a bit of a, that 40 with 31 looks a bit weird. It looks a bit low. So it kind of dips down a bit there. So drawing that on. Yeah, the trick for drawing curves is that you need to draw one continuous line, and you need to kind of skewer each of the points that you plot. So you don't want to miss the points, and you don't want to draw multiple lines. Okay, other than that, you're allowed to have a little bit of like wiggle wobble with your line drawn in between. Like I say, this one's kind of got a bit of a weird hump there at 30, but that is where the data says, and I did double check it, so it must be good. Okay, other than that, I'm happy with my graph. Right, so find out which club has younger members on average. Give evidence to support your decision. Okay, well, the easiest average to find here is going to be the median. Now, the median is going to be, you find your midpoint of your data. So I've got 64 data points for both. So median, which we call Q2 often, is take our 64 values. Well, you would normally add 1, but with the amount of 64, it doesn't really matter so much. I'm just going to do 64 divided by 2. It's the 32th value. Okay, average is kind of in the middle. Okay, so the middle of 64 is going to be at 32. And then we're going to read across from 32 until we hit both curves. And then we're going to read down. So there. So if I draw on a line to hit both curves. Oops. And then draw down. You can have the median for the tennis club here. Sorry, the cycling club. And then the median for the tennis club is going to go there. Okay, so the median for the tennis club is going to be, what's that, 51. And then the median for the cycling club is a little bit younger, it's 42. Okay, so which club has the younger members on average? It's the cycling club, because the median is 42 compared with the tennis club's 51. Okay. Question 16. A salesroom sells various types of cars. Some cars are electric, some are petrol, some are both, and some are neither. The Venn diagram below shows the salesroom stock of cars. A petrol car is picked at random. Find the probability that the car is also electric. So we want the probability that it is electric given that it is petrol. That's the actual probability we're finding. That's how we would write it down using correct notation. The probability of getting an electric car given that it's a petrol car. In other words, a petrol car is picked at random, so we're only picking from this group here. So we're picking from those. Okay, and what is the probability that the car is electric? It's going to be that section of those petrol cars, isn't it? So that's the ones we're working out. So the probability that it's electric given that it is petrol is going to be the 17 electric cars, which are within 17 plus 8, which is 25, within the 25 petrol cars. Okay, so that's what we're working out. So the probability that it's electric given that it is petrol is 17 over 25. Question 17. Find the equation of the line through 4, 5 that is perpendicular to y equals 2x minus 3. Okay, so let's have a think about this. So we've got a line which is y equals 2x minus 3. So what does that look like? So if I quickly sketch that. So there's my axes. 2x minus 3. So it's going to be a fairly steep line passing through minus 3, isn't it? So that's my line. Y is equal to 2x minus 3. So there's going to be a point on that line which is 4, 5. That's the point 4, 5. And our line is perpendicular to that line, y equals 2x minus 3. So it's going to kind of go in this direction through that point up here. Okay. Now you might be wondering why I'm sketching it, and the reason I sketch these things is your sketch tells you stuff which you can then use to just double check your work in. So just looking at my sketch, I know that the gradient is going to be negative, and I know that the y-intercept is going to be kind of positive up here somewhere. So yeah, it tells me stuff, and I just think it gives you a good understanding of the problem before you kind of crack on and do it. It only takes a few seconds, and I think it's a good thing. Right, so let's work it out then. So I know the gradient of my original line, gradient of y equals 2x minus 3. I'm going to call that m1, and that's equal to then this value here. Then that's the gradient of this line. It's just going to be equal to 2. Okay, it's the coefficient of the x term when you've rewritten it in the form y equals mx plus c. Y equals mx plus c. So your gradient is there. Look, just the number in front of the x. Okay, so I know m1 is 2. Now, if it's perpendicular, then gradient of new line m2 is going to be the negative reciprocal of that then, isn't it? It's going to be, take that number, flip it over and put a minus sign in front of it, because that's always the case for lines that are perpendicular. One is the negative reciprocal of the other. Okay, so therefore equation of this new line is of form y is equal to m2, which is minus a half x plus c, some y-intercept that I need to go on and find. Okay, do I know any points that it goes through? Yes, I do. It goes through that point there. So I know that the line passes through 4, 5. So I can sub those values into the equation, and then the only thing I won't know there is c, and then I can find out what c is. So subbing in y is 5. So 5 equals minus a half lots of x, which is 4, plus c. Okay, so negative half lots of 4, that's minus 2. So then c, taking that to the other side, would be positive 2. So that's going to be c is equal to 7, isn't it? Okay, so therefore equation is y equals minus a half x plus c, which I know is 7. Okay, now again, I'm just drawing the fact that I drew a sketch, and I can use, when I look at my answer, it gives me confidence that I'm working correctly. I was expecting the gradient to be negative. I was expected to be fractional. I did actually draw my red line a little bit shallower than it should have been. Probably would, if I'd have drawn it a bit more like a 2 gradient, it would be a bit more clear that this one was going to be fractional as well as negative. But yeah, it's still sloping down, so I'm happy with that. And I was expecting the y-intercept to be up there somewhere, and I've got a positive c. So yeah, quick sketch helps you check your work as you go along. Question 18a. The next term in the Fibonacci sequence is found by adding together the two previous terms. The first and the second term of a particular Fibonacci sequence are x and y. Show that the fourth term of the sequence can be written as x plus 2y. Well, kind of goes with the turf, doesn't it? So like u1, the first term, is equal to x. u2, we're given the second term is equal to y. So then u3 is going to be those two added together. It's going to be u1 plus u2, which is x plus y then, isn't it? And then u4 is going to be u2 plus u3, which is y plus x plus y, which is x plus 2y. Okay, so there we go. u4 is x plus 2y. Right, so the second one, the fourth term of the same Fibonacci sequence is 7. The seventh term of the sequence is 31. Work out the value of x and the value of y. You must show your working. Right, now in order to work this out, I might just continue what we were doing here to find an expression for u7, because we've been given the value of the fourth term, which I know is algebraically x plus 2y. But if I carry on doing the same thing, I'll come up with an algebraic term for the seventh term as well, won't I? So u5 is going to be my third term plus my fourth term, so x plus y plus x plus 2y, that is equal to 2x plus 3y. u6 is going to be u5 plus u4, so that's going to be x plus 2y plus 2x plus 3y, so that gives me 3x plus 5y. And then u7 is going to be those two terms added together, so that's going to be 5x plus 8y. Okay, so u7 is 5x plus 8y, and u4 is x plus 2y. So, and we know what they're equal to, so we can form a pair of simultaneous equations here, can't I? I can say that my u7 one, so from u7 I've got 5x plus 8y is equal to, we're told it's equal to 31, and we've got our u4 term, which I know that x plus 2y is equal to 7. So I can go on and solve these two simultaneously, can't I? Okay, so if I call this one equation 1 and this one equation 2, then if I take the second equation and I times it by a factor of 4, I should end up with 8y's in both then, shouldn't I? And then I can kind of eliminate the y's. Okay, so multiplying that one up by a factor of 4, I'm going to get 5x plus 8y equals 31, which I already had, and now I've got 4x plus 8y is equal to 7 lots of 4 is 28. So then subtracting those, 5x take away 4x is x, and 31 take away 28 is 3. So I know x is 3, okay? And then what's y then? So sub in my x value back into U4. So substitute x equals 3 into, I called it equation 2, didn't I? Into equation 2. So I'll get 3 plus 2y is equal to 7. So then 2y would be 4, making y is equal to 2. So y is 2. Okay? So x is 3 and y is 2. So then the sequence, just to double check that, I suppose we could generate the sequence then, couldn't we? So if the sequence went 3 and then 2, then the third term would be those two added together would be 5, and then 5 plus 2 is 7. 5 plus 7 is, what's that? That's 12. 7 plus 12 is 19. 12 plus 19 is 31. Yeah, so you can see here that my fourth term was 7 and my seventh term is 31. So it does kind of work. Happy with that. Good job. Let's move on. So 6 marks. Wow. Part B says here are the first 4 terms of the sequence. We've got 1, root 3, 3, and 3, root 3. Now this sequence, I hope you can see, has a common ratio. Each one is root 3 more than the previous one. So 1 times root 3 is root 3. Root 3 times root 3 is 3. And 3 times root 3 is 3 root 3. Okay, so it has a common ratio of r, which is equal to root 3. Okay, so that makes this sequence what we call a geometric sequence. Okay, so it's a geometric progression or sequence. Okay, and the nth term of a geometric progression is simply the first term, a. What is the first value? A is 1 times by the common ratio to the power of n minus 1. Okay, so if you think about it, that's a, that's AR, that's AR squared, that's AR cubed. So the nth term is going to be AR to the n minus 1. Okay, so the nth term of this sequence is going to be my first term, which is 1 times my common ratio of root 3 raised to the power of n minus 1. Okay, so just making that a little bit neater. Well, times everything by 1 just disappears. I've got root 3, which is 3 to the power of a half, I guess, is another way of writing it, to the power of n minus 1. And then so combining that together, it's going to be 3 to the power of n minus 1 over 2. Is a slightly neater way of writing it then. So 3 to the power of n minus 1 over 2. Part C says here's the first 4 terms of a quadratic sequence. We've got minus 1, 5, 13, 23. The nth term is n squared plus bn plus c. That's just the general form of the nth term of any quadratic sequence. You can just see it's a quadratic expression, isn't it? So find the values of b and c. Now there are different ways of doing of working out the nth term of a quadratic sequence. Some people just do it by finding common second differences and halving that and whatever. I kind of like to do it algebraically because I'm a maths teacher. So what I would do, I would say, well, when n is equal to 1, so my nth term u1, or my first term u1, so if I've got my nth term is n squared plus bn plus c, and n is 1 because it's the first term, I've got 1 squared plus b lots of 1 plus c. So that's going to give me 1 plus b plus c then, isn't it? Okay, so my first term u1 is 1 plus b plus c. Now my second term u2, when n is 2, I'm going to get 4 plus 2b plus c. Okay, now I know that u1 is the first term here, it's -1, so this is equal to -1, and I know that u2, the second term, is equal to 5, so I know that this is equal to 5. Okay, so I've already got a pair of equations in b and c that I can go on to solve here simultaneously. Now I'm just going to take that expression for u1 and tidy it up a little bit. So if I take 1 away from both sides, then I'm going to get b plus c equals, well, I'm going to take 1 away from both sides, I'm going to get -2. And for u2, taking 4 away from both sides, I'm going to get 2b plus c equals, 5 take away 4 is 1, isn't it? So that's my equation 1, that's my equation 2. Now how can I simplify these? Well, if I take equation 1 away from equation 2, so equation 2 minus equation 1, so just kind of subtracting uphill here. So 2b take away b is b, plus c, c take away c is nothing, and then 1 take away -2 is 3, isn't it? So that gives me b is equal to 3. So then substituting b is equal to 3 into equation 1 again. So I'm going to get 3 plus c equals -2. So that makes c equal to -5 then, doesn't it? So therefore our un, our nth term, is going to be n squared plus 3n minus 5. Okay, and that means that b was 3 and c was -5. Okay, now I could just double check it at this stage to make sure it works. So if I've got n squared plus 3n minus 5, when n is 1, I'm going to get 1 squared plus 3 minus 5. 1 plus 3 is 4, take away 5 is -1. It fits. And then for n is 2, 2 squared is 4, plus 3 lots of 2 is 6. 4 plus 6 is 10, take away 5 is 5. That does work, and so on. You could just add in your number, evaluate for the various values of n, and just check it's the same numbers as the ones in the sequence given. Okay, mine works, so I'm happy with that. I'm going to move on. Question 19. Describe the single transformation that maps the graph of y equals x squared onto the graph of y equals x plus 3 all squared plus 5. Okay. Now, pulling up this handy table of the various transformations of graphs that you need to know. You need to know 6. You need to know 2 translations, 2 reflections, 2 stretches. Now, I think you can see that if I take y is equal to x squared and I go to y is equal to x plus 3 all squared, then my function in x is going to f of x minus k. This is a translation of 3 units. Well, it's actually -3, isn't it? Because this one's plus, this one's minus. So it's a translation of -3 units in direction of x. Okay? Now, and then once I do that, so then if I did that one first, if I translated it 3 units to the left, and then I take my y is equal to x plus 3 all squared, and it goes to y is equal to x plus 3 all squared plus 5, then that is a second function, f of x, going to f of x plus k outside the bracket then, where k is 5 in this case. So that's going to be a translation of 5 units in the y direction, isn't it? In direction of y. Okay, so in other words, our graph is equal to like x squared like that. So each point on our graph is going like 1, 2, 3 units to the left and 1, 2, 3, 4, 5 units up. So then my curve is my second curve is going to look like that, isn't it? Okay, which I hope you can see is a translation then. So if I was describing that as a single translation, okay, I'd be going -3 in this direction and 5 in that direction, wouldn't I? Okay, so my graph is going 3 units to the left and 5 units up. So to describe that as a single transformation, I would say that is a translation of using vector -3, 5, like that. So it's a single translation using that vector -3, 5. Okay, so the x coordinate is changing by -3 and the y coordinates is changing by 5. Now for these you just need to learn those 6 translation types and be able to recognize what's happening with simple algebraic expressions to work these out. Question 20. Mrs. Sweet has 8 different milk chocolates and 9 different plain chocolates. Her daughter chooses one of the milk chocolates. Her son then chooses one of the plain chocolates. Mrs. Sweet then chooses one of the remaining chocolates. Work out how many different combinations of the 3 chocolates they could choose. Okay. So we've got 3 chocolates, haven't we? So we've got choice 1, we've got choice 2, and we got choice 3. Okay, now choice 1 and choice 2 are fairly straightforward. So with this one, her daughter can choose any of the 8 milk chocolates, can't she? So there are 8 choices for this one here. So it's just going to be 8 for this choice. Now the second choice, again, is fairly straightforward. There are 9 different choices for the chap. Now for Mrs. Sweet, it depends. Either she picks one of the remaining milk chocolates. So after her daughter has picked one, there should be 7, or she picks one of the remaining plain chocolates, which after her son has picked one, there should be 8. So either 7 or 8. So altogether she's got a choice of 15 different chocolates, hasn't she, here? So she's got 15 different choices. Okay, so then to work out the total combination, then you're going to multiply these together. So our 8 choices for the daughter times our 9 choices for the son times the 15 choices that Mrs. Sweet gets. So what is that then? 8 times 9 times 15, that comes to 1,080. Okay, so 1,080 choices. Question 21. 60 people each try to solve a puzzle. The table summarizes their recorded times. 12 people solved it between 0 and 5 minutes. 19 solved it between 5 and 15. 18 people solved it between 15 and 30. And 11 people solved it between 30 and 50. Draw a histogram to show this information. Okay. Now, a histogram has frequency density on its axes here. So we need to work out what the frequency density is for each of these first. So I'm just going to add an extra column to my table called frequency density. Now, frequency density is equal to frequency divided by class width. So to work out the frequency densities of each of these, we need to know how wide each of the classes are. So the first class is going from 0 to 5, so it has a width of 5. The second class goes from 5 to 15, so that spans 10 units. 15 to 30 has a gap of 15, and 30 to 50 has a gap of 20. Okay? So then to work out frequency density, we're going to divide frequency by class width. So the first one is 12 divided by 5. 12 divided by 5, that's 2.4. Next one, 19 divided by 10, that's going to be 1.9. 18 divided by 15, 18 divided by 15, that comes out to be 1.2. And 11 divided by 20, 11 divided by 20, that is 0.55. It's not a very nice one. 0.55. Right, so to draw this then, I'm going to have to draw a rectangle for each one of these amounts. So my first rectangle has a width of 5 going from 0 to 5, a height of 2.4, so it goes up to about there. Okay, that's my first bar. Make it a bit thicker so you can see it a bit better. Maybe not that thick. Yeah, like that. Okay, next one goes from 5 to 15 and it has a height of 1.9. So from 15 would be to there, then we're in at 1.9 here. Okay, and then 15 to 30 has a height of 1.2. And then finally 30 to 50 has a height of 0.55, halfway between 5 and 6, so 2, 3, 4, 5, 5.5, like that. Okay, I'm happy with that. Part B says, those people who failed to solve the puzzle within 50 minutes were given a recorded time of 50 minutes. Nina uses the mid-interval values to estimate the mean recorded time of the 60 people. Explain why Nina's answer is likely to be an underestimate of the mean of the actual time taken by the 60 people. Okay, so what we're doing there then, so to work out the mean, so we're taking the mid value of each of these bars, aren't we? So 0 to 5 would be like here at 2.5, and then this would be at 10. This one would be halfway between 15 and 20. It's going to be 22.5, something like that. And then here we're going to be taking that as 40, aren't we? Because that's halfway between 30 and 50. But what we're actually saying is, well, you know, anyone who was longer than 50 or failed to solve it was just rounded off to 50. So this last bar could have been a whole lot wider, in which case the midpoint would be further off, in which case, what does that mean? So that would mean that this value for here, your estimate here would be bigger than it otherwise would. It means the value would be greater, wouldn't it? Some people may have taken longer than 50 minutes, so the actual midpoint would have been higher than 40. Okay, that's why I think it would be more. Question 22, solve algebraically x squared plus y squared equals 18 and y equals x minus 6. We've done lots of solving simultaneous equations today, but this one is a different method. We're not going to solve by elimination here, we're going to be solving by substitution. I'm going to call this one equation 1, I'm going to call this one equation 2, and I'm going to be substituting equation 2 into equation 1, which means where I see the y written in x squared plus y squared equals 18, I'm going to write the value of y. I'm going to write x minus 6 there in its place. Okay, so what I'm going to get is x squared plus the value of y in the second equation, x minus 6, and that is equal to 18. Sorry, squared. Okay, so squaring that bracket there, I'm going to get x squared plus x squared minus 12x plus 36. I'm using the identity to do that quickly. I'm using a plus b squared equals a squared plus 2ab plus b squared. If you use that, you can just kind of do them fast. Otherwise, you could just write as two brackets. So x minus 6, and kind of do FOIL on it. Either way, you're going to get x squared minus 12x plus 36, and that is equal to 18. Okay, so collecting like terms, I've got two terms in x squared, so that's going to give me 2x squared. I've got one term in x, got minus 12x, and I've got 36, and if I bring the 18 to the other side, it's going to be minus 18, so 36 minus 18 is 18, and that's equal to 0. Okay, now note everything is even, so I can halve everything to make it a bit more simple. So that's x squared minus 6x plus 9 is equal to 0. Okay, looks like that factorizes fairly easily. So it's going to be x minus 3 in there, isn't it? It's another perfect square. So that gives me x is equal to 3 and x is equal to 3 is a repeated root. Just substituting x equals 3 into equation 2, the simpler one of the two, I'm going to get y is equal to 3 minus 6. In other words, y is equal to minus 3. So x is 3 and y is minus 3. Okay, that one was quite straightforward. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.